Hello, this is Vlado from ViDi Labs. In this short video, I will show you how you can use a ViDiLabs calculator to measure large, tall or wide objects at a distance at places where you can't probably access, or you may need it for your installation. You may want to know how much of coaxial cable or how much of network cable you need for a particular building, but maybe you don't know what is the width of the building. There is a way how you can do it, and I'll show you how that is done. So this is a photo of a lighthouse in Kayama, near where I live. And this is a photo taken by my smartphone, in this case iPhone XS Max. And what I've done, I have taken a photo so that I have full height of the lighthouse in the field of view. Now, the only thing I needed to do while I was on site is to measure the distance from the point where I'm taking the photo to the lighthouse. I didn't have any meter as such or laser meter, but certainly I know how long are my steps, so I paced it out and I measured about 40 meters. And obviously there is a little error there, but pretty sufficient for me to find out approximate height of this lighthouse. The interesting thing is I have no idea what was the height of the lighthouse, and I'll show you later on through a data that actually the calculation would be pretty much spot on. Now, as you know, a ViDiLabs calculator is usually and typically promoted for usage in the CCTV or IPVSS systems, for calculating the angles of view, pixel density for CCTV cameras. But as I said in some of my videos, this calculator works with any camera, including obviously the smartphone's camera. In fact, I already have number of measurements and number of video in the training that we actually know for sure that the actual optical quality of smartphones often exceeds the qualities found on CCTV cameras, especially with their distortion. In fact, you will find out that a lot of smartphones will have minimal barrel distortion when you're seeing wide view, almost unnoticeable. One of the videos that I have when we were discussing the wide angle of view barrel distortions, which is the reason why I suggest to not rely on pixel density of any calculator, not just ViDiLabs. Pixel density with very wide angle lenses that have barrel distortions are inaccurate because of the optical imperfection of what it's supposed to be. But as long as you have that knowledge and check it yourself, you can always take pictures of your smartphone of object that is reasonably with parallel lines, horizontal, vertical. You can easily see whether there is obvious distortion or not. In this case, I know for sure that my iPhone XS Max doesn't have any noticeable distortions. So for that reason, I rely on the optics quality. So it is important to have good optic quality, as good as you can get it, of course. But in this instance, I'm pretty confident this optic quality is good. Then, once I know that I'm taking the full height of the lighthouse, and I know what is the distance, all I need to find out is what is the sensor size and the pixel count of this picture. Now, there is an easy way to find out, but I'll just explain why I'm doing that way. You would expect that you can find all these details on manufacturer's website, for example, in this case, Apple website, but there is no really clear data because this is not a CCTV camera, and what the manufacturer is giving you, in this case Apple, is giving you the equivalent focal length of full frame camera, angle of view. That means, like, I've got two lenses on this smartphone, as you can see here, top and bottom. So top is usually the wider view, the bottom one is usually the telephoto. So the wider view, the manufacturer says, gives you an angle of view equivalent to 26mm lens on a full frame camera. So being photographer in spare time, I know what it means in terms of angle of view, so that's reasonably wide angle, which we can also find through the ViDiLabs calculator if we wanted to. but the bottom part they say gives you equivalent of 52 millimeters focal length. Now clearly this is equivalent focal length relative to the full frame, not for the actual sensor. So I do not know really what is the absolute focal length of the lens on this smartphone. But luckily we have with every digital camera, and this is actually applicable to any smartphone, doesn't have to be Apple, could be Android, Samsung, Nokia, they all have metadata or so-called EXIF data, always comes with a picture that you're taking. So by using just any standard photo editing software such as Adobe Photoshop, or in my case I'm using Affinity Photo, you always will find the details of the actual camera metadata, which is camera type iPhone XS Max, manufacturer maker is Apple, it tells you the date. Now this is important, the size of the picture that I have is 4032 by 2268 pixels. And the focal length is, as you can see here, 6 millimeters. So this is the focal length I need. So this is genuine, true focal length that is on the telephoto camera. I have taken this photo by selecting 2x optical. I have chosen the telephoto lens, which means when I'm taking the photo, in the actual photographic menu of this smartphone, I can choose 2x. So the phone switches from the wide angle top camera to the telephoto lens, and I know that telephoto lens is now 6 millimeter because I know I've selected 2, and I know that is an important one. You could obviously use the first one if it is something bigger or taller, but for that position I found that I have exact height of the Lighthouse by selecting the second camera, which is again 6 millimeter. And now just a little clarification here with the pixel count. I know that most of the smartphones these days, at least majority of them, not all of them, use about 12 megapixel as a typical resolution for the photographic back camera. That is the full frame, not full frame in terms of photographic, but the complete pixel count of the actual sensor. Now as you can see here, the actual size is 4032 by 2268. I know that Apple has advertised that 12 megapixel is 4032 by 3000 and something. I have selected the actual aspect ratio of this photograph to be 16 by 9 in the setup of my camera menu. Therefore, and for that reason, the vertical height is not 3000 pixels but 2268, which is basically the aspect ratio of 16 by 9. So I like to take my videos and photo at 16 by 9. So if we remember these numbers, 2268, that is important for us to find out now the size of the sensor. This is another thing that is not clearly disclosed on Apple's website. In fact, I searched high and low and it wasn't possible to find the sensor dimensions. However, in a lot of professional photographic sites that are testing and analyzing smartphones, I have found that for this particular phone, that the top sensor, the top camera on the smartphone XS Max has pixel size of 1.4 micrometers, which is roughly what I would expect, and the bottom one has a pixel size of 1 micrometer. So in other words, the actual two different cameras have two different size lenses, which is why probably Apple doesn't necessarily disclose and confuse people that you've got two different sensors and two different focal length lenses. The smaller sensor would provide telephoto lens. If the sensor was bigger with the same focal length, will give you wider angle of view. So I know that 1 micrometer is the camera that I'm using, which means if I multiply 2268 by 1 micrometer, that the vertical height of the sensor is 2.27 millimeters. Horizontal would be about 4 millimeters. So let's now enter into the ViDiLabs calculator these values and let's see what we get. Okay, so we have here the visual screen of the ViDiLabs calculator, the default visual screen. So I haven't entered any numbers here, so I'll show you how that is done. So the first thing we said we need to do is enter the correct image sensor dimensions. So first let's enter the horizontal sensor width of 4 millimeters. and we said the vertical will be 2.27, so double tap on 3.6 and enter 2.27. Okay, so the dimensions of the sensor is 4 mm by 2.27. This is the bottom telephoto camera on the iPhone XS Max. We did say that the pixel count, which is the next thing we need to enter, is 4032 horizontal and 2268 vertical. 68 vertical. So we have entered the image sensor dimensions and pixel count, which was the first thing usually we would do with the ViDiLabs calculator. Once we know this is correct and we know the lens is okay, there is no reason why we wouldn't get a correct measurement of the scene height, which is in our case the full height of the lighthouse. So this is something that will come up at the bottom here on the right hand side. So we said that I've pasted the distance to the actual lighthouse to be 40 meters. So let's enter in the distance 40 meters. 40 meters. So now we say we need now to log this distance because we need to set the focal length to 6 millimeters, if you remember. So let's hold 1 second at the distance and double tap into the focal length and enter 6 millimeters. Okay. So we are getting here a scene height of 15 meters. If my math is correct, and if this sensor has that many pixels, and the dimensions are, as is shown here, 2.27, that means the height of the lighthouse in Cayama is about 15 meters. So let's see now what is really the case. Okay, let's search for Cayama Lighthouse. Here's a picture of Cayama Lighthouse, the one that I took photo of. Let's see if we can search for Cayama Lighthouse height. Okay, Wikipedia probably will be the best place to see. Tower height 16 meters. Okay, so now that's okay. Tower height is 16 meters. Obviously that would be with the top antenna, which I think in my case I chopped it off a little bit. Let's go back to the photo. Here's the photo again. As you can see here, there is a little pointer there with a wind indicator, so that probably would be about maybe half a meter or so. And at the bottom we are just touching the ground, so if we add that, I'm not going to try and fudge the numbers, but as you can appreciate, this seems to be about 15 meters. With adding this at the top, at the bottom probably will come close to what the actual lighthouse seems to be according to Wikipedia. Let's see if there is any other structure. Well, it says something here. New South Wales 15 meters. New South Maritime, which says 15 meters. So there you go. In any case, the calculation shows pretty accurate. So basically, I'm happy to tell you that this is a very nice way to measure things in the distance, and using the similar logic and the similar reasoning, you can pretty much measure anything that is inaccessible to you, maybe on the other side of a particular area, and you probably don't have to actually pace it out. Like it doesn't have to be an object. What you can also determine that way, and actually probably I'll do one more case study example, you can measure the distance to a ship, ocean liner, on the horizon, as long as you know the actual length of that ship, and typically I would say the tankers are like 300 meters, maybe 400 meters, depending upon the size, but they're more or less standard. So if I know that by taking a photo and a tanker in the distance, I can measure how many pixel width that tanker is, I can multiply across the length of 4,032 pixels how many of these tankers can get in there. That will be my width of the picture at that distance, and then with the ViDiLabs calculator you can find how far that is. So that's as simple as that. Anyway, that was the interesting example of using ViDiLabs calculator to measure height and width, providing you have at least the distance to it, or as I suggested, you may want to know the distance to something that is inaccessible or something far away, as long as you know what is that object, and as long as you know what is the approximate, let's say, length of that object, if that goes that way, then you can pretty accurately calculate using the same logic. As long as your optics is reasonably good, not barrel distortion, I'm pretty sure you will find this reasonably accurate, probably better than using laser distance meter over, I don't know, 10 kilometers on the horizon. You probably can't do it anyway. That's it. I hope you enjoyed this interesting trick that we can use with ViDiLabs calculator, and stay tuned for some more interesting applications. See you next time.